Hi, this is Veronica Ramirez, and I'm presenting my midpoint summary project for Spec 6327. And this is just an introductory slides to present key findings and in modules 1 through 4. So the first point is going to be validity. In reviewing the standards and the coursework in the module, I've come to understand that this is the most fundamental consideration when evaluating test scores and developing tests. Inferences are made, and we need to determine whether or not those are justified based on test scores that are received. And so that is a big part of the process, if not the most fundamental consideration in that. The next consideration is going to be reliability. Reliability is the index of the consistency of performance under varying conditions. And I've pictured a scale here. So for example, if a toddler hops onto this bathroom scale and consistently weighs 40 pounds, which is actually 5 pounds over her true weight, the scale is reliable because it's consistent and it's consistent in its measure, but not valid because it doesn't actually measure the true weight. And so reliability is a very important fundamental tenet in statistics. The next is the measurements, and we went over 4 types of measurements, and those are nominal, ordinal, interval, and ratio. And the summary is found in the table here. And the only one that has the 0 is the ratio. The nominal is basically the measurement, which just has the name. One of the examples we did in class was that helped me to understand nominal would be the jerseys that are assigned to players that have numbers. It's just the number or the name. With ordinal, they're actually arranged in order. However, and there's degrees of difference, but there's no inherent 0 in the ordinal. So the way I remember is going to be ordering something from, a toddler, an adolescent, a young adult, an adult, and you can actually, there is some degree of difference in them, and you can arrange them in an order, but you can't subtract the data values, and there is no inherent 0. With interval, there is a difference between the variables equally, but again, there is no inherent 0. You can't order them. And then with ratio, there is a meaningful 0 point in that data set. They can be arranged, put in categories, you can subtract, and you can determine if one data value is a multiple of another, and there is, again, that inherent 0. Okay, central tendencies. So we went over mean, median, and mode, and we talked about a symmetrical distribution in a data set. So basically, the central tendency helps to find the middle or the average in a data set. And the mean is going to be the average, which is where you take all of the numbers and you add them together, and then you divide that by how many numbers are in the set to get the average. The median number is going to be the middlemost number, so that's where you would arrange the numbers in order, and then you would find the middle number, and if there wasn't, you have an even or odd number set, you would take both of them, and then you would get the average that way to obtain the median. And then the mode is going to be where you have your data set, and then it's going to be the most frequent number that is in the data set. And here pictured is going to be a positive skewed curve, and where you see where the median, this is the central tendencies here. Let's see. This is a symmetrical. You've got all of those central tendencies right in the middle. This is going to be a bell curve. And then this one over here is positively skewed because you see that the median and the mode are going to be on this side over here. And then this would be negatively skewed. You see that it's on the bell curve. I mean, the curve is over here and the median is going to be to the left. Okay, moving on to the next slide. Variability is actually very important consideration, and this is the part that actually tripped me up the most in the modules and understanding this. So I'm going to try to give it my best go in understanding that, but basically the variability is going to talk about the spread of the data set. And so the standard deviation is going to be the measure of how spread out, or the variance or the variability that the numbers are in the distribution. That is the standard deviation. So again, it's the measure of variability that takes into account each and every score, and it's used to develop the measurement in relation and relative position that can be used to compare scores in different distributions. And so you have two different types. You have the variance and you have the standard deviation. In the standard deviation, again, it's the difference from the mean, and you would use that by getting the square root of the variance. The variance, again, is how far and how spread out that is, and it's represented by sigma squared, and the standard deviation is the square root of that variance. And so there's a chart here that kind of, there's a little key right here that shows you the x1 is the data set values, and then this is the mean of the actual data set. So the variance here is, again, standard deviation is the square root of the variance, and then the variance is the it's, if I can say this correctly, it's represented by this Greek symbol here, and it's squared. So these are basically the same thing. It's just this function right here. It's the square root of the variance. And then this is measuring how far the spread is. And it's the average of the square of the deviation, or the standard deviation. I hope I got that right. Okay. So now we've come to the z-score. And the z-score, simply put, is how many standard deviations away a particular data point is from the mean. And we use it in a normal distribution. A t-score is going to be used with a smaller sample size. And so the mean of a t-score is going to be 0. So I've kind of included this flow chart. If the sample size is greater than 30, then you would use a z-score, and if it's a smaller sample size, then you would use the t-score. One other thing that I've learned is that in the Z distribution, with the normal distribution, the mean is 0 and the standard deviation is 1. Okay, scale scores versus standard scores. So standard and scale scores are both obtained or transformed from other scores, usually raw scores. But the standard score will follow a normal distribution or the bell curve. Scale scores don't necessarily have to follow that. The scale scores, basically, the standard score is transformed and the mean is 0 and the standard deviation is 1. That's what's scaled. There's also normalized standard scores that have the advantage of equal interval scales, and they range from 1 to 99 with a mean of 50 and a standard deviation of 21.38. And there is an assumption that it's a normal curve. Now, some of the issues with interpreting standard scores have to do with the norm reference group, and if it's not the same, then there could be different scores. So that is one issue. The other with grade equivalency, there's interpretation of grade equivalency scores that are problematic sometimes when the performance is too far away from the expectation. So there's a lot of caution that has to be used around standard scores. So to close out and make sure I've covered or at least touched on as much material as possible within the 4 modules, there's a distinction I wanted to make that I've learned: the criterion reference and the norm reference assessments. Criterion reference being assessments that measure a criteria or a scale. It's usually pass or fail. Those are more common with measuring TEKS or a particular criteria. Whereas a norm reference assessment, there's norm reference tables or groups that are used of previous test takers that have taken it, whether they be national norms or local norms. And you want to see where they measure or where they fall within that category. And so a test, it's basically a comparison of test takers' performance to performance of other people in a specific reference population. And that is the distinction. The caution with the norm reference group is that you want to be sure that it's measuring that particular group, or it's a reflection of that particular group, and there's no bias in that. We did touch on that in class. Equating and calibration, we talked about linking versus equating, and equating is like the practice of placing 2 or more tests on the same scale and satisfying the construct they have to in order to use those test scores interchangeably. So having a form A and a form B, making sure they measure the same construct but they're equal. And whereas in calibration occurring after the test, not necessarily prior to testing, where they still measure the same construct but they're not of the same ease or difficulty, and there has to be an adjustment that's made after the fact to make sure that they are reflective of, or they're equal, and so that process has to occur. That is a very, very basic analysis, or my understanding of it. So hopefully I've covered most of the items. I'm still learning, but I love this assignment because it had me reflect on what I knew, and where there was gaps, I had to kind of go back and say, wait a minute, let me make sure I understand that right. So very reflecting on it, it was a very good experience. And the next slide is my references. So I will show that now, and that is my presentation. Thank you.